Good morning. This is the first video for Math 83 when we will be talking about factoring. And I'm using a brown marker. I hope it shows up well. That looks pretty good. Okay, so whenever we're talking about factoring, in our class we're talking about factoring polynomials. However, we can factor a number. So let's factor 24. Now there are lots of ways to factor 24. We could factor 24 into 6 times 4. Those are factors of 24. We could also factor 24 into 12 times 2. We could also factor 24 into 8 times 3. And then 24 times 1, but that one's not really helpful. But there are lots of ways we could factor 24, but there's really only one way we can factor it into factors that can't be factored anymore, if that makes any sense. So that's called the prime factorization, and we did this back whenever we were reducing fractions. So no matter how you start, if you keep factoring the factors, you end up with a unique factorization. So in this case, it would be 2 times 2 times 2 times 3. And that is the only way 24 can be factored into prime numbers. So numbers that cannot be broken down further. So we know how to factor numbers. What we're going to be interested in this video in particular is factoring polynomials using greatest common factor. All right, now if you're following along in the notes, you know what greatest common factor is. It is, first of all, the first step, no matter how we're factoring a polynomial, is to try and take out a greatest common factor. And it is the number or collection of variables that everything in the polynomial contains as a factor. And the important word there is everything. So everything in the polynomial has to contain this as a factor. If any term of the polynomial does not contain it, we cannot take it out as a greatest common factor. So we abbreviate greatest common factor GCF. Okay, so let's look at how we find a greatest common factor and then how we factor it out. So here's an example. This is part A. 2x squared minus 22x plus 60. Okay, so that's a polynomial, and like we talked about in the last class or maybe a couple classes before, this is a polynomial in one variable because we only see x as a variable. All right, so now let's look and see what is something that every single term contains. Well, let's start with 2x squared. It has factors of 2 and then 2 factors of x in it. So now let's check these other terms. Does this one have a factor of 2? Yep, 22 has a factor of 2. Does it have 2 factors of x? No, it just has 1 factor of x. So for these two, the most we could take out of these two terms is a factor of 2 and 1 factor of x, because that's all they contain. But we still have this other term over here. Does it have a factor of 2? Yep. Does it have any factors of x, though? No, I don't see an x there at all. I just see 60. So if we're looking at all three terms, our greatest common factor here, the thing they all contain, is a 2. And that's it. So if we wanted to factor out the 2, what we do is we write the 2. That's our greatest common factor. And we open up a set of parentheses. And we write what's left if we take 2 out of all of those terms. So if we divide this term by 2, all that's going to be left there is the x squared. If we divide this term by 2, we'll have a minus 11 and the x. And if we divide this last term by 2, 60 divided by 2 is 30. And so that's what it looks like to factor out a greatest common factor. We write our greatest common factor out front, and then we make a set of parentheses that leaves the leftovers there. Now, you don't have to check this if you don't want to, but you can. So if you want to check it, you would just distribute out what you got. And what we should end up with is the same thing we started with. If we end up with something different, we have not factored correctly. So we should be able to distribute this factor of 2 through that set of parentheses. And sure enough, 2 times x squared is 2x squared. 2 times minus 11x, remember we can put the numbers together and the variables stay like they are. And then 2 times 30 is 60. And we check and make sure, and that is the first thing we started with. So we factored correctly. So a good thing to remember here is that whenever you're factoring, you're not supposed to be changing anything. You're just going to change the way this thing looks. Just like with 24, whenever we multiply 24 or 2 times 2 times 2 times 3, we should still get 24. It just looks different. It's written in its factors. So you should end up with something that is the same, but just looks different. It's written as factors. Alrighty, let's do another one with greatest common factor. Okay, so here's part B. We're going to look at 4x to the 4th minus 8x squared plus 16x. All right, now remember with greatest common factor, we're looking at something that every term contains. So if we start out looking at the 4x to the 4th, that has a factor of 4, which means it also has a factor of 2 and 2. And it has 4 factors of x. So let's keep going to see what the others also contain. So if we look at minus 8x squared, it has a factor of negative 8, which means it also has factors of 4 and 2. And really 3 2's if we want to break it down more precisely, and then 2 factors of x. So far, the most number of x's that we can take out of these terms just from these two is 2 factors. Now let's look at 16x. Well, 16 has factors of 8 and 2 and 4. So it looks like so far we're pretty good taking out a factor of 4 from each of these 3 terms. We think about a bigger thing we can take out and no, because the biggest thing we have here is a 4. So the biggest number we can take out of all these terms is a 4. Now let's look at our x's. This one has 4 factors of x, 2 factors of x, 1 factor of x. What we're looking for is the most factors of x that they all contain. That's going to be just 1. This one has 4, this one has 2, this one has 1. The smallest number they all contain is 1 factor of x. So that's the most we can take out of every term. So that's our greatest common factor. So to factor it using greatest common factor, we're going to write greatest common factor out front. And then in parentheses, we're going to write what's left over if we factor out a 4 and an x from every term. So if we factor out a 4 from here, well, that just leaves us with a 1. You can write it if you want to, but you don't have to. And if we factor out 1 factor of x from this first term, it leaves us with 3 factors of x. And we do a quick mental multiplication. If we multiply these together, we get right back here at 4x to the 4th. So that's good. Now let's look at this next term. Minus 8, if we factor out a 4 from negative 8, that's going to leave us with negative 2. We had 2 factors of x in this term, and we're wanting to take out one of them. So that leaves us with one of them. Do a quick multiplication. 4 times negative 2 is negative 8. That's good. X times x is x squared. That's good. Finally, 16x. If we factor out a 4 from the 16, that leaves us with a 4. And if we factor out 1 factor of x, that's all that's there. So if we factor this factor of x out, we don't have any more x's. So we're done. Do a quick check. That's going to be 4x to the 4th minus 8x squared plus 16x. And we're done. We factored out the greatest common factor there. Okay, we'll look at a couple more just to make sure we're good with this before we move on. All right, so this is part C in our notes. And this one's a little crazy. Because we have 2 variables in this one. But that's okay. It's not going to change how we do greatest common factor. So we have x's and y's here. But we're going to do the same thing. We're going to look term by term and determine what is the most that they all have in common. So if we look at this first term, it contains a factor of 3, 2 factors of x, and 2 factors of y. Next term, we have an 18. So there's still a factor of 3 in there. We can take a 3 out of 18 and still be left with something. We have 1 factor of x and 1 factor of y. So far, these two terms each contain a 3. They each contain at least 1 factor of x and each contain at least 1 factor of y. But we can't do it like that yet because we have that third term to consider. And it's got to have whatever we plan to take out if we're going to take it out. So the 12 definitely has a 3. So 3 is something that can be taken out of every term. Now let's talk variables. So these two had a factor of x in it, but this one doesn't. So x cannot be part of our greatest common factor because they don't all have one in it. This one has 2 factors of y, this one has 1 factor of y, and this one has 1 factor of y. So each of them contains at least 1 factor of y. So I can take a y out of each term. So that can be part of my greatest common factor. Okay, so we're ready. Let's write our greatest common factor out front. Then in parentheses, we write what's left. So if we factor a 3 from 3, that's just a 1. We're not going to bother writing it. X squared, well, that's going to stay there. And then we have a y squared, and we're taking 1 factor of y away, which means we have 1 factor of y left over. Do a quick multiplication. We multiply these two together. We get 3 x squared, y squared. Exactly what we should get. Next term, negative 18 divided by 3. If we take a factor of 3 away, that leaves us with a factor of 6. And don't forget your negative. We didn't do anything with the x, so the x is still there. And we took this factor of y away out front. So that's all that's left when we take away the 3 and the y. Then finally we have this 12y, so we know we can do 12 divided by 3. Don't forget your plus, that'll leave us with a 4. And just like with the 18, the y that was there is taken out. So we're done. Do a quick multiplication if you want to check. We already checked this term, but that gives us 3 x squared y squared. Negative 18 xy, if we do these two together, and 12y. So we did it correctly. We took out the greatest common factor correctly. Okay. I want to show you this next one just to show you something that you can do if necessary, and it'll become necessary when we start talking about factoring by grouping, and also the next example will too. All right, so let's look at 2x squared plus 3x plus 5. Okay, so we want to try to do a greatest common factor here. So this first term contains a factor of 2 and 2 factors of x. So that's our best candidate now for greatest common factor is 2 and x squared, I guess. So let's go on to the next term. 3 does not have a factor of 2 in it, so 2 can't be part of our greatest common factor. We had 2 x's here, and this one has 1x, so our greatest common factor could have an x in it, but we still have one to check, this plus 5. Well, 5 does not have a factor of 2 and does not have a factor of 3. So far for our numbers, we have no number that can come out of 2, 3, and 5 as a factor. And it doesn't have an x in it, so we also can't take out any x's. So we haven't really found a greatest common factor that's worth anything, it feels like. Just to let you know, though, if there's nothing that they all have in common, they always have a 1 in common. Now, this is not very helpful now, I admit it. Taking out a 1 here is not helpful at all in this case, but it might be later. So if we take out a 1, we're just left with the expression itself. So in this case, it's not very helpful, but you are allowed to do it if it's something you need to do. And this is something that will come up whenever we do factoring by grouping in the next video. Another thing that'll come up is something that's kind of weird, but is allowed to be a greatest common factor if you need it to, kind of like the 1. So let's look at something like this. Now, this looks strange. It looks different from what we've seen so far because we've got some strange terms here in parentheses or some strange pieces in parentheses. But let's look at these two pieces as terms. This is a term, and this is a term. And we're going to try to see what they have in common. Don't think too hard about this. Just look at both the terms. This one has a 4 and an x plus 1. This one has a minus 3y and an x plus 1. So this piece, the x plus 1, is present in both terms. That can be your greatest common factor. And you're going to factor it out just like normal. So we're going to factor out the x plus 1. Looks weird, but it's the same. And then we write what's left in each term if the x plus 1 is gone. So in this term, if we take away the x plus 1 factor, we're left with this factor of 4. In this term, if we take out the x plus 1 factor, we're left with a factor of minus 3y. So again, this will really come into play in the next video when we start factoring by grouping, but that is it for greatest common factor.